So the one thing I will guarantee this year is, unlike last year, you're not getting rickrolled at the end of the presentation. So this will be my 2025 to 26 winter weather forecast. I realized too late that I forgot to put my disclaimer slide in here, so here we go. This is a long-range forecast is for my general sense of what may happen in the oncoming winter. This is not a, this is for sure happening, nor is it excuse for not to be prepared for any extreme weather event that may happen. All right, now that that's out of the way, let's keep going to our scorecard. And yeah, let's just say I'm not really that happy with this. This is my worst performance since the winter of 2019-20. The misses were the water year rainfall, the temperature departure, and the valley snowfall department. And I did get a few comments saying, well, it snowed. Yeah, it didn't snow 6 inches or more, so that's just a flat out miss in my book. For the hits, the only one that was a clear outright hit was the most active time, because the first half of February was the one that came out the strongest in my analog years. Then the other one that came out as a hit was the peak wind gust, because my analog years last year did show that a big wind event was likely, but may not hit Portland, it may miss Portland. And the North Coast got hit pretty bad, along with the eastern side of the Puget Sound. The half hits were the April 1st snow depth. It's too complicated to explain in 3 minutes or less. And the lowest winter temperature under 20 degrees. It really depends on where you were at in the valley. Some urban areas actually did manage to get below 20 degrees, but it was concentrated mainly in the southern Willamette Valley. So, moving on to my methodology, I use an adjusted analog year approach using the Oceanic Nino Index. I specifically, before 1950, used what's called the Ensemble Index, which reconstructs the ONI going back to 1850 as well. I confirmed this using the Southern Oscillation Index. I also use the Pacific Decadal Oscillation and then the Quasi-Biannual Index. One mistake I made last winter was that I failed to consider that the westerly phase of the QBO can make the polar vortex stronger when combined with peak solar cycles. So I'm correcting that for this year. Analogs are not weighted equally. Analogs that are closer to this year will have a higher weighting, where adjustments to analog years can be made using statistical analysis as well if there's a statistically likely or unlikely chance of something occurring. General trends based on the previous seasons will also be used when appropriate. And then all forecasts will cover what has happened out of essentially 1/3 of the years at the Portland airport. And then for adjustments to data in the past when necessary, snow prior to the 1970s have been adjusted to a 4.3-inch average per winter on my analogs, which has been our average since then. Further adjustments can be made if necessary for marginal setups back in like the 50s and prior, because newsflash, it was a little bit cooler back then compared to what it was today. Secondly, temperature departures have been adjusted to the averages at the time of which they occurred, not using today's averages. And then third, since downtown Portland was used for analogs before 1940, I converted the precipitation over to a PDX equivalent, so that is 83.8% of what downtown gets. All right, let's move on to the data and the oscillations that we use. First off, the ENSO 3.4, these are the set of models that I like to use, and when going through my analysis, I find that if I use these 7 models here, the overall average comes out within 1/10 of a degree every year I use these 7 models. So this shows pretty much a borderline La Nina. I'm not convinced it's going to stay in La Nina for long. It may only just be for about a 2-3 month period at best. One thing to note is that if it does stay in ENSO neutral, that does heighten the odds for a major windstorm, as pretty much all of our major windstorms in the Pacific Northwest have happened with either an ENSO neutral year, a weak La Nina, or a weak El Nino. Southern Oscillation Index over the last 2.5 years. Last year it was firmly in the positive phase. This year it looks to be positive, but not quite firm positive yet, though I do anticipate that that will get a little bit closer to positive as we go into the upcoming months. PDO, firmly negative. It has been creeping back up a little bit, but when you're coming from record low, you're still going to be in the negative phase at that point. One thing I do want to touch on a little bit this year is the return of the blob, specifically the North Central Pacific, as we see here, that blob of above normal temperatures. I do want to note, however, that this is a look at the last 9 days of sea surface temperature anomalies, and those anomalies in the Northwest and North Central Pacific have been cooling off a little bit, along with off our coast. However, the Northeast Central, that's a mouthful, Pacific, has been warming up a little bit. So could see the PDO dip a little bit more negative as a result when the October numbers come out. And then QBO values, we are now in the easterly phase. So that signifies that the polar vortex likely will be a little bit weaker this year, though the base state for QBO easterly does tend to lean slightly drier than normal. So a little bit not typical for a La Nina, just looking at that alone. Sunspot count near the maximum that was declared, what was it, August of 24, I believe. Don't quote me on that, I don't have that note in front of me. Then let's move on to our analog years and our statistics. So I have 27 analog years this year with, just like last year, 5 top analog years. One of the things that did go well last year is that I did about half of it ENSO neutral and half of it weak La Nina. I'm doing the same thing again this year, and the analog year that worked the best last year was my oldest analog year, 1886 to 87. That's not carrying over this year. A couple of them from last year are, so my top analog years this year are 1893 to 94, 1921 to 22, 1967 to 68, 2013-14, and 2017-18. This is the first time I've given a winter forecast where 2 of my top analog years have been since 2000. So comparing the analog years and what has happened, specifically the top analog years, so for the oldest one, 1893 to 94, that was a weak La Nina. The PDO was primarily negative, though there was a quick blip into a neutral PDO before going back into the negative phase firmly. 1922 to 23 was a super cold neutral that briefly dipped into La Nina before going back into ENSO neutral. Very similar to what I'm expecting for this year. PDO also negative with a blip. It was closer to the solar minimum than what we are experiencing this year, though. They're looking for our quote-unquote modern 3 years. 1967 to 68 was another La Nina light year. That wasn't an official La Nina, but it did experience La Nina conditions occasionally through the winter, and a negative PDO with a blip as well. QBO was also easterly during this time. QBO data only goes back to about 1953 reliably, so I did not use that for the first 2 analog years. And then for 2013-14, this one was a ENSO neutral year, a little bit on the colder side, but never got into the La Nina territory. PDO started negative that winter, but it did deteriorate as it went on, and it flipped into the positive phase the summer following that. And then QBO did not match as well. It flipped to the westerly phase. The sea surface temperature chart did match the best here, as there was a marine heat wave as the original blob was developing then. 2017-18 was on the borderline between a weak and moderate La Nina with a negative PDO that was just starting to develop. It was borderline negative neutral. And QBO was flipping to the easterly phase then, and the sunspot progression was closer to the solar minimum then than it was in 1967 to 68 or 2013-14 than we are now. In terms of the extreme events that happened, let's start with the 2 oldest years. 1893 to 94, short cold snap in early January. Not a lot of snow came out of it. There was more marginal setups later in the month. Probably wouldn't happen today. I saw a lot of 34-degree snow with that. And then in February, 5 inches of marginal snow earlier in the month, followed by a late season cold snap with another 5 inches. This one was interesting because there was a sub-freezing high on the 20th, but lows stayed in the 20s. So I don't have wind data from that far back. It was a likely east wind event, just looking up the temperatures from that. 1921 to 22, that was the ice storm of the century mentioned earlier by Mark Nelson. If you want more details, please go to the November meeting. The only part I will mention is that there were 6 inches of ice in spots and up to 54 inches of snow was reported in the gorge. On top of that, there was a December Arctic blast in Portland with 3 sub-30-degree highs, lows stayed in the 20s, so it was a likely east wind event with some cloud cover because snow and some sleet occurred on most of the days there. Another mid-January cold snap, but only 1 inch of snow happened, and then in late February, dry and breezy cold snap. And then looking at the modern analog years here, 1967 to 68, mid-December cold snap with 4.8 inches of snow at Portland, though no sub-freezing highs. And this one primarily was Portland focused, so if you are from the South Willamette Valley, you got essentially nothing from that one. Late January cold snap had 2 to 12 inches of snow valley-wide. It had a sub-freezing high in most areas. Then for our warm weather lovers, you're gonna love this one. It hit 70 degrees on February 28th, 1968. For the skiers, not a great year for a La Nina light. 60% of the average peak snowed up that year. 2013-14, it was a double peak winter with December having a Arctic blast and a major South Valley snowstorm that canceled finals. And then negative 10 degrees happened at Eugene, our second coldest all time. Second more shallow Arctic blast occurred in February with more widespread snow and ice and absolutely nothing in between. Barely anything even on the rainfall department. Slow cascade snowstorm, but it did recover as we got into February and March. 2017-18, we had a white Christmas. And nothing until February afterwards. A little bit more snow there, I think it was 6.6 inches, and it was a bad cascade season by La Nina standards. In terms of the all analogs, it did come out a little bit better. The cascade snow average was about 92% of normal when I average all my analogs out. For the water year rainfall, the all analog median came out to be a little bit below normal, 35.37 inches. Top analog median about 32 inches, and then the weighted analogs about 35 inches. The water year rainfall down in Eugene came out 38 inches. The top analog median came out to be about 34 inches, and so did the weighted analogs. For reference, Eugene's average rainfall is about 41 inches, so about 4 inches more than PDX. So the temperature departure from average at PDX or downtown Portland prior to 1940, the median was about 0.6 of a degree below average. A lot of clusters right around the near normal mark, and then again right around 2 degrees below normal. Top analog median about 0.2 of a degree below normal. The weighted analogs came out about 7 or 3/4 of a degree below normal. In Eugene, a little bit stronger of a case for below normal this year, median about 0.35 of a degree below normal, top analog median 1.5 degrees below normal, and the weighted analog median about a degree below normal. Lowest wintertime temperature at PDX or downtown prior to 1940, median came out to be 18 degrees, top analog median 16, and then the weighted analogs came out to be about 16 degrees as well. And then in Eugene, median also 18 degrees for all of our analogs. The top analog median at 19 degrees, and then the weighted analogs at 9 degrees. And then just for reference, on my top analog years, 2013-14 for Eugene had about 35% of the weighting for the weighted analog, so that skews it down, so I did adjust that in my final forecast for Okay, next up is our adjusted snowfall for PDX. The all analog median came out to be 4.7 inches. The top analog median 7.3 inches, and the weighted analog median 6 inches. Not a lot of low snow years. We just had one no snow year in these analogs, and then going further back a couple of them in the 1 to 2 inch range. But also not a lot of extreme snow years. And then in UG, the all analog median of 3 inches. The top analog median is also right around 3 inches, but the weighted analogs, again, did get skewed higher because of 2013-14 at 7.1 inches. And then also as a sidebar with this, UG did not record snowfall between about 1995 and 2012, so all the snowfall here shows as 0, but they may not all be 0. Right, so historically significant trends and statistics. The elephant in the room here is that there's been 10 winters in a row with snowfall. This is a record high. Chance of an 11th occurring is only about 2.7% if you ignore, and so if you ignore everything else. Because my analog years disagree with that, I have decided to ignore that. Only 3 winters have had a temperature under 20 degrees with less than 1.5 inches of snow. All of them had 0 snow, one of which was a strong La Nina. 5 winters in a row where the total days with snow on the ground have been above the median. The median is 1.5 days with snow on the ground. If we do get 2 days with 1 inch of snow or more on the ground, that would raise the median up to 2 inches. Chance of a 6 occurring, again, if you ignore analogs, would be about 1.5%. On the contrary side of things, for the cold lovers here, there has been no deep Arctic blast, which I define as 12 degrees Celsius at the 850 millibar level over Salem for 11 winters. Why I decided on that specific temperature is because if you descend a air parcel adiabatically in a perfectly dry environment, that air parcel would stay below freezing all the way to the surface. If you raise this temperature even just 0.5 of a degree, you would now be above freezing at the surface. Chance of a 12th occurring if you ignore the analog year is about 4.7%. And then correlations with past seasons, second year Niñas almost always have a drier winter season. So that only applies to December, January, and February. Does not necessarily apply to the rest of the year. Questionable status of last year's ENSO brings this into question because it wasn't an official La Nina, more like a La Nina like Tanya mentioned. And for how often it occurred 13 out of 14 times at PDX and 12 out of 14 times in UG, so pretty good hit rate in that case. And for reference, last winter we had 14.06 inches in December, January, and February, which was 94% of average. So with all that being said, let's move on to our predictions. So with the water year, I'm tilting a little bit below average with 30 to 38 inches in Portland and 33 to 42 inches for our friends in the South Valley. My best estimate is 33 inches, splitting the difference between my top analogs and all analog medians, and the South Valley, 37 inches there. Temperature departure, near to tilting below, up to about 2.5 degrees below average. I will note that this is a pretty low confidence prediction, especially at PDX because of those 2 separate clusters. Windstorms, the top analog years didn't come out with a lot of the big time wind events, but there were a lot of the events that were in the 50 to 55 mile per hour range, so a decent storm is possible. So I'm anticipating a peak gust between 50 to 60 miles per hour, a little bit tamer in Eugene just because they're a little bit more wind sheltered. Lowest temperature, I'm anticipating below 20 degrees. Best estimate is about 16 degrees with that. Most likely to be active. I think a double peak is the most likely scenario, with December and February being the most likely of that double peak. February came out stronger than the December timeframe, however. With the double peak, I did notice a trend on the top analog years especially. I only use the top analog years for the extreme events, is that one of these will be less than a week. So like using December as an example, it could just be around Christmas, and then the rest of the month is in the 50s. And then on to our snowfall. For mountain snow up on April 1st, a little bit below normal is my best estimate. I can't rule out being near normal. Best estimate would be probably right around that 92% all analog median or so. And the valley snowfall, 1 to 3 decent storms, net total of about 2 to 8 inches valley-wide. I anticipate Portland will do a little bit better this year than the South Willamette Valley. Best estimate about 6 inches for Portland. 4 for the South Valley. Chance of a no-snow winter is about 20%. So that is it for my presentation. And then one comment for the recent microburst we had. So I'm a runner. I ran the Chicago Marathon the day of the microburst. So a non-scientific reason why it happened was I ran round and round and round the city. And the moment I collapsed is what triggered the microburst. So thank you.